Hello and good morning, students. I welcome you all to Brihan Bombay Municipal Corporation Education Department Online Education for English Medium. We are conducting online education for class 9th. Subject which I'm going to take today is science, and the topic which we are seeing is substances in common use. And today the subtopic which I'll give you is bleaching powder, washing soda and soap. This is the second session of this chapter. My name is Ms. Bushra Maqsood Ahmed and our channel nodal officer name is Mrs. Almas Hannure. Chapter number 14, substances in common use. Right, students, in the first session, I have taught you about the substances which we are using in our day-to-day life. What are their substances? What are the properties and uses of that substances? Right? So in that we have seen some salts, right? So what are the salts? I have taught you in the last lecture. Salts are what? They are ionic compound which do not contain H plus and OH minus ions, right? And contain only one kind of cations and anions. These are called simple salt. This all type of simple salt, these all things and the daily use things I have taught you in the last lecture. Today we'll see a small recap of the last session. Then we'll start a new topic. So students, we have seen what? We have seen a common salt, that is table salt. What is the name of that table salt? Sodium chloride, right? What is this chemical formula? NaCl. Na stands for sodium and Cl stands for chloride. Sodium chloride is formed by neutralization reaction between hydrogen oxide, sodium hydrogen oxide and hydrochloric acid. Aqueous solution of salt is neutral in nature, hence its pH value is 7. Now see students, we have discussed that sodium chloride is formed by what? It is formed by neutralization reaction. Neutralization reaction means when acid and base reacts together gives us salts and water, that is nothing but neutralization reaction, right? So here is what base is NaOH and what is acid HCl. What we obtain NaCl salt plus H2O, that is water. Now as we have discussed about the pH scale, right? When universal indicator is added to a solution and the color which we obtain, we just match it by, we compare it by pH scale, and then we're able to understand what is the strength of acid and strength of base, or whether it is neutral in nature. So when I compare sodium chloride solution with this pH scale, when I've added universal indicator, what I have seen, I have seen that it is neutral in nature. If it is neutral in nature, what will be its pH value, students? Its pH value will be 7. Okay. Now, properties and uses. What are the properties and uses of this common salt? Common salt is colorless, crystalline, ionic compound. Now, see, we all know that common salt is colorless and it is crystalline ionic compound. Crystalline ionic compound means what? When we feel it in our hand, we just feel like some crystal structure, right? So hence it is termed as crystalline ionic structure. There is no danger of crystallization in this crystalline structure. Now see, when the salt which we have obtained, it is come by the process of crystallization, okay? But when we feel it, we doesn't feel it wet, like we feel it completely dry, means there is no water in it. Water of crystallization is not there in its crystalline structure. Next point, it is neutral salt and salty in taste. Yeah, it is neutral in nature and it is salty. When we taste a common salt, sodium chloride, it is salty in taste. Its compound is used for the production of salt like Na2CO3 and NaHCO3. Now students, see, as we have discussed that this common salt is used for the production of other salts also, such as NaCO3 and NaHCO3. From that we have seen what is NaHCO3. NaHCO3 is what? Sodium bicarbonate or sodium hydrogen carbonate, that is nothing but baking soda. Okay. Now see students, the next point we have discussed about the electrolysis process, right? When when we take a container and when we put a solution of saturated solution of sodium chloride. The saturated solution of sodium chloride is also termed as brine. And when it is electrolyzed, it is electrolyzed means what? When we put two rods in this solution, and when we connect this two rod to the electric cell, so one will be act as cathode and other will act as anode, right? And when we pass the electricity, when we pass switch on the cells, what we will see, we'll see some reaction takes place in the solution. What reaction we will see? We will see that in this electrolysis process, hydrogen gas is released at cathode. Now see, hydrogen gas has positive nature and cathode is negative nature. So hydrogen gas will attract towards cathode, while chlorine gas is released at anode. As chlorine is negative nature, it will get attracted to the positive terminal. So anode is positively charged, hence chlorine gas is what? It is released at cathode. Now say this electrolysis process is used for the production of which gas, students? Chlorine gas. Below we have shown the chemical reaction. NaCl plus H2O give us NaOH plus Cl2, chlorine gas is released, and then hydrogen gas is released plus H2O. See, this electrolysis process I have explained with the help of what? With the help of a diagram. See, in a beaker, we have taken Na saturated brine, that is NaCl plus H2O water. When both cathode and anode are just connected to the cells, and when we switch on the cells, what we see that H plus gas, that is hydrogen gas, is associated with cathode, while Cl gas, that is chlorine gas, is associated with anode. This whole process, students, is termed as electrolysis process. Now see, when salt is heated at a high temperature, about 800 degrees Celsius, it melts. Now see, when salt is, what is the melting point of salt? It is very high, at very high temperature, that is about 800 degrees Celsius, salt melt, and this is known as what? Fused state of the salt. When fused salt is electrolyzed, chlorine gas is released at anode and liquid sodium metal at cathode. Now see, when this fused salt is electrolyzed, see, as we have just electrolyzed sodium chloride plus water, so when this fused salt after melting, when that is electrolyzed, student, so what we see, that liquid sodium metal is associated towards cathode. We have in the last session I have shown one video, also very beautiful video, to explain this electrolysis process, right? Today just I'm just giving a quick recap of all this topic, so that when I teach you the next topic, you will remember what the topic which we have discussed in the last sessions. Now see, this second salt I have taught you about, sodium bicarbonate. Sodium bicarbonate is what? A baking soda, right? This baking soda which your mom is using to prepare what? Spongy cakes, to make bhaji crispy. This all things to make a household eating items which we are making at home. So which salt your mom is using? For crispy nature, for spongy nature, to make a porous substance such as bread, right? So baking soda is used. What is the chemical formula of this baking soda? Chemical formula of baking soda is NaHCO3. Okay. Now see, baking soda is a white non-crystalline powder. See, when we take baking soda in our hand, what we see, that it is very smooth. We doesn't feel any crystalline structure. We do not feel some crystal with our hand. We feel that this powder is very smooth powder. So what it is, if it is smooth, so we will say that it is non-crystalline powder, right? It is not. See a photo of baking soda also I have shown you. Its chemical name is sodium hydrogen carbonate or sodium bicarbonate. See, it is termed as sodium hydrogen carbonate also, or sodium bicarbonate also. If any one of the name comes in your MCQs, that what is the chemical name of baking soda, and in option you have given sodium hydrogen carbonate or sodium bicarbonate, both options are right. And its molecular formula is NaHCO3. Now we'll go to the properties and uses of this baking soda. NaSCO3 reacts with moist litmus paper and red litmus paper turns blue, which means that it is basic in nature. Now see students, when NaCO3, in that if we take a solution of NaHCO3, that is baking soda, and when we put both litmus paper, whether blue or red, what we will see that there is no change in blue litmus paper. But what is the change in red litmus paper? We'll see that this red litmus paper will turn to blue. As red litmus paper turns to blue, what is the conclusion, students? We can term that, we can conclude that that solution is basic in nature. It is used to make bread, cake, and dhoklas. I was already told you that it is used to make what? Bread, cakes, and dhoklas. Being basic in nature, it is used to reduce acidity in the stomach. As it is basic in nature, so it is used what? It is used to reduce acidity. See, whenever we feel acidity, what we take enos, right? In enos also baking soda is used. The other substance which are used to remove acidity is what we take antacids, right? In antacid, what is there? Milk of magnesia is there. Milk of magnesia is also basic in nature. So this all things are used to remove what? To remove the acidity which we feel in our stomach. NaSCO3 is used to make the active substance CO2 in the fire extinguishers. Now see, in chapter number 13, we have discussed in carbon and carbon compound, carbon and important element, we have seen the fire extinguisher, right? In fire extinguisher, what are the things we have seen? We have NaHCO3 in that. Then we have sulfuric acid. When this both get react, so which gas is released? CO2 gas is released, right? So in this fire extinguisher, CO2 gas is released with the help of NaSCO3, that is nothing but sodium hydrogen carbonate or sodium bicarbonate. Okay, students, so this make a very important role also for in a fire extinguisher. Now, baking soda is used to clean an oven. Now, see, to clean an oven, we know it's very difficult to clean an oven, yeah, with the help of the dish bars and all this. But with the help of baking soda, if we just put some baking soda in our oven, we can very easily, we will able to clean our ovens also. So see, there are so much uses for this baking soda. It is used for cleaning purpose also, for fire extinguishers also, to remove acidity also, to make the eating things also, right? So there are numbers of uses of baking soda. So these all things we have discussed in the last chapter. This was a small recap. Now we will go to our today's topic, that is we are seeing bleaching powder. We all know bleaching powder, yeah, as we hear the term bleaching powder, the one things come in our mind what bleaching powder are used for, which purpose? Washing purpose, to wash a white shirt, right? When we see that a white shirt is very dirty, so your mom always use bleaching powder, told you to go bacha, go and bring bleaching powder from market, I want to wash your white shirt. It's become very dirty and become very difficult to clean that, right? So see, this the bleaching powder which we are using in our home, that's what is the chemical name of that bleaching powder? It is calcium oxychloride. What it is, bacha? It is calcium oxychloride. And what is the chemical formula for this? Chemical formula CaOCl2. Well, Ca stands for calcium, O oxy means oxygen, and Cl2 is chloride, that is CaOCl2. Now see, when you remember the chemical formula, now you can easily just can say the chemical name of it as CaOCl2. We can easily say Ca is for calcium, O will be for oxygen, Cl2 will be for chloride. So we can easily tell, yeah, the chemical name of this will be calcium oxychloride. Now see how calcium oxychlorides are obtained. We will see this. Bleaching powder is obtained by reaction of chlorine gas with slaked lime. We know slaked lime, yeah? Slaked lime is nothing but, bacha, it is CaOH2. That is calcium calcium hydrogen oxide. Calcium hydrogen oxide is what? CaOH2, that is slaked lime. When it is react with chlorine plus Cl2, what we obtain? We obtain CaOCl2, that is bleaching powder, plus H2O, that is water. See students, when slaked lime reacts with chlorine, See, I have explained you with the help of chemical reaction. See, in this chemical reaction, CaOH2 plus Cl2 both are getting reacted, and what the product we have obtained, that is CaOCl2, that is bleaching powder plus H2O. We'll go to the next point. Bleaching powder undergoes slow decomposition due to the carbon dioxide in air and chlorine gases released. Now, see, student, when we just see, when bleaching powder is opened up, yeah, when we keep some bleaching powder, it goes what, it goes very slow decomposition take place in the presence of carbon dioxide in the air. When we all know, in air which gas is also present, carbon dioxide gas is also present. So this bleaching powder is getting react with carbon dioxide also, but the decomposition which is taking place is very slow. And what are the product we are obtaining? That is CaCO3 plus Cl2, chlorine gases released back. Okay, so CaOCl2, that is calcium oxychloride, plus CO2, that is carbon dioxide, both reacts together give us CaCO3, that is calcium carbonate, plus Cl2, that is chlorine gases released. But remember, the decomposition process which goes on in the presence of carbon dioxide is very slow. Now, we'll see the properties and uses of this bleaching powder. What are the properties and uses of this bleaching powder? Bleaching powder is yellowish white colored solid substance. When we see what is the color of this bleaching powder, we see that it is yellowish white, right? It is little yellowish white color solid substance. The chemical name is calcium oxychloride. Its chemical name is calcium oxychloride. It has a strong odor of chlorine gas. But see, when we just smell this bleaching powder, it has a very strong odor of chlorine gas. Fourth point, it is used for disinfection of drinking water at the water works and the water in swimming pool and destroy the microbes in the water. Now see, students, during rainy season, okay, when we open our taps at our home, what we feel a strong some odor is coming out, right, from the water which we are using. That odor is nothing but it is the odor of chlorine gas. Now see, why we get the odor of chlorine gas from this water? Because this bleaching powder, the chlorine gas which is released from this is used for which process, students? Disinfection process. Okay, bleaching powder is used for this, sorry students, it is used for disinfection of drinking water. Okay, so see, this is one use of, that is, it is used for disinfection of the drinking water at water works, yeah, from where we get a water. Again, in swimming pool, the water which is used, it is also disinfect with the help of this. Why? Because it destroys the microbes in the water, the harmful microbes which are very harmful for us, which is dangerous for us. It kills that microbes and make it as infection free. We may disinfect it and we can able to use that water for our daily uses. Now see, it is used for bleaching of the cloth. Now see, for bleaching of the cloth also, bleaching powder is used. It is used for disinfection by the roadside and garbage side. Now see, we see in the rainy season, the roadsides becomes very slippery, right? We see numbers of algae, fungus, all the harmful microbes are grown on the roadside, which make it very slippery, right? So for this, what we see, the municipalities peoples come and they throw some powder on it, right? On the garbage side also, most of the smells are coming out. So they are just pouring out some water, some powder. So which powder they are using? They are using bleaching powder. This bleaching powder is useful for disinfection for the roadside, so that all the algae and fungus and all the microbes, the harmful microorganisms which are this which are present there get destroyed. They get, and the roadside become disinfect, and same thing with the garbage sides also. Now see, students will see some reaction of this with some acids such as sulfuric acid and hydrochloric acid in the next point. Dilute sulfuric acid and dilute hydrochloric acid reacts rapidly with bleaching powder to release chlorine gas completely. Now see students, when dilute sulfuric acid or dilute hydrochloric acid, it reacts with bleaching powder, but the reaction is very rapid, very quick. And when this reaction takes place, so totally chlorine which is present in the bleaching powder is released, the full chlorine gas is released. See, I've explained you with the help of chemical reactions also. CaO, Cl2 plus H2O, that is sulfuric acid, give us CaSO4 plus Cl2C, complete sodium chlorine gas is released plus H2O. So see students, this is all what the properties and uses of bleaching powder, right? It is used for making disinfection for drinking water, for swimming pool, for bleaching of clothes, washing of clothes, then disinfection for the roadside and garbage side. So this all are the properties and uses of bleaching powder. The last property I'm showing you, that calcium oxychloride reacts slowly with carbon dioxide to form calcium carbonate and chlorine. We have discussed this point previous right now, that calcium oxychloride reacts very slowly with the carbon dioxide to form what? Calcium carbonate and chlorine, while it reacts very rapidly with which students? So dilute sulfuric acid and dilute hydrochloric acid, and fully the chlorine gas is released, rapidly it is released. So you have to remember that bleaching powder, that is calcium oxychloride, reacts very slow with carbon dioxide, but it reacts very rapidly with what? Dilute sulfuric acid and dilute hydrochloric acid. Next is washing soda. We are seeing. Now see student, washing soda. Washing soda, the chemical formula is Na2CO3 dot H2O. Dot H2O means what? In its crystallization, what is present? Water molecules are present. Na2CO3 is sodium carbonate, and in that what is present? H2O, water molecule, is also present. Now see students, will see what is washing soda used, what are the purpose of this washing soda. The hard water from a well or a bore well becomes soft on adding washing soda, and we come to know this from the lather formed on it. Now see student, we know that the water which we obtain from wells or bore wells, it is very hard water, and how we just know it, that when we just add some soaps in that water, we form some leather, right? Some scums are generated. The layer of dirt is known as leather or scums, right? So with the help, with by observing that, we can determine that yeah, this water is hard water. But when washing soda is added in this hard water, this hard water becomes what? It becomes soft water. Okay, and it is readily to use. The hardness of water is due to the presence of chloride and sulfates of calcium and magnesium in it. Now see, the hardness of the water, why the water is so hard? It is hard due to the presence of what? Due to the presence of chloride and sulfate of calcium and magnesium in it. Means whatever the sulfates of chlorides and sulfates of calcium and magnesium is present in it, it is due to that. Na2CO3 is added to it to soften such water and make it suitable for use. Na2CO3, that is washing soda, is used what? It is used to soften such water and make it suitable for use. The reactions with Na2CO3 causes the formation of insoluble carbonate salt of magnesium and calcium. Now see, when this Na2CO3, see the reaction with Na2CO3 take place. Now see, when the reaction with Na2CO3 causes the formation of what? It causes the formation of insoluble carbonate salt of sodium, sorry, salts of magnesium and calcium. Now see, when MgCl2, that is aqueous solution of magnesium chloride plus Na2CO3 gets reacts together, we get what? We get a carbonate salt of magnesium, that is MgCO3. That is, we get a salt of magnesium, carbonate salt of magnesium, plus what we have obtained, NaCl, that is sodium chloride. See here in the photograph, I have shown you what? I have shown you washing soda. Now see, sodium carbonate is a water soluble salt of sodium crystallines. Sodium carbonate is a water-soluble salt of sodium. What do you mean by this line? Now see, it is water-soluble. Whenever we add water in this washing soda, it gets completely soluble in this. Now see, crystalline sodium carbonate on keeping loses its water of crystallization readily and a white powder is obtained. This is called washing soda. Now, see, students, as we have seen in the market, when we just buy washing soda, right, what we see that it is some yellowish color, right, but when we keep it for some time, we see that it loses, and what we obtain, a white color is obtained, right? Now see, when Na2CO3 dot H2O, means this washing soda is kept openly, right, it's kept openly, what is there? It loses its water, it loses its water, and what we obtain is a white powder washing soda we are obtaining, that is Na2CO3 and some amount of H2O, that is water. Now see, on when we are keeping this when we are keeping this sodium carbonate water openly, so the water molecules is present in it get what? It get evaporated, from the solution, and what we obtain? We obtain a pure washing soda. Now we are going to see what? We are going to see properties and uses of this washing soda. Washing soda is a whitish and odorless powder at room temperature. Now see, washing soda is what? It is a whitish color and no odor. We don't get any odor. It is an odorless powder at room temperature. Litmus has blue color in its aqueous solution. When we put red litmus paper in its aqueous solution, what we obtain? We obtain that the red litmus paper turns to blue, which means what? Which means that it is basic in nature. Third point, it is hygroscopic. That is, it absorbs moisture if left exposed to air. Now, Chi, what do you mean by the term hygroscopic? Hy- Hygroscopic means when the substance is exposed to air, it absorbs what? It absorbs moisture. It is used mainly for washing clothes. For washing clothes, this washing soda is used. Now students, see, sodium carbonate is used in glass and paper industries and also in refining of petrol. See, sodium chloride, it is used in which industries, students? Glass, paper industries, and also for refining of petrols also. Now see, this are the things which we have seen: bleaching powder, washing soda, Then this all things we have seen, baking soda, salt, but there are another some crystalline salts which we are using in our day-to-day life. Some crystalline salts in our daily use which contain water of crystallization. They are alum. Alum, see, can you see the first photograph? Alum is nothing but fitcree. You know fitcree? So fitcree is also useful for disinfection, right? So what is fitcree? Alum is potash alum, that is K2SO4 dot Al2SO4 3 24H2O. Then the next one is borax. See, borax is also using for in a laundries for cleaning purpose. See, this is second one is borax, Na2B4O7 10H2O. Then Epsom salt. Epsom salt is what the third figure is of Epsom salt, that is magnesium sulfate. There's MgSO4 7H2O. Barium chloride, BaCl2H2O. Sodium sulfate, then also known as Glauber's salt, Na2SO4.10H2O. So these all are the crystalline salts which we are using in our day-to-day life. Now see, alum fitcree, right? Alum is used for the purification of water. Now how it is used for purification of water? We see that when we put alum in our water, we just take 2 to 3 rounds of alum in the water. What we see, it becomes a property of coagulation. What do I mean by coagulation? Because of the property of coagulation, the solid impurities in the water comes together, becomes heavy and settle to the bottom. As a result, the water above becomes clear. Now see, the alum is used for water purification process, and it is due to the property of coagulation, right? When we put some alum in a water, we see that the solid impurity which are present in the water, it becomes heavy and it gets settled down in the bottom, and the water which is above, it becomes clear and ready to use. Borax is a powdery white substance known as sodium borate. It is widely used as a household cleaner and a booster for a laundry detergents. Now see, this borax powders are as same as of washing powder. This borax powder is also used, also termed as sodium borate, and is widely used for a household cleaning purpose also, right? And it is also booster for laundry detergent. With the detergents, when borax powder is used, so the cleaning process, the cleaning of the clothes get very easily. Okay, so these are using for the laundry purposes also. Now see students, very interesting topic, soaps, right, which we are using for which purpose, student? Bathing purpose, right? So below I have shown you the photograph of a soap. There are numbers of soap. Now we get a number of varieties of soaps, we get a number of flavors in it, the smells, everything. So there are number of varieties present in of soaps are present, right, in a day-to-day life. We have seen this. Now, what are these soaps? How these soaps are formed? We don't know that thing. So we are going to learn what are soaps right now. When oil or animal fat is boiled with an aqueous solution of sodium or potassium hydroxide, sodium or potassium salt of carboxylic acid, fatty acids are formed. These salts are called soap. Now you will tell, ma'am, you have just read it, we don't understand anything. Okay, I'll explain you. Now see, when oils or animal fats, right? Oils or animal fat, it is boiled. It is boiled with what? It is boiled with an aqueous solution of sodium or potassium hydroxide. In, right? This animal fats or oil is boiled with, it is boiled with a aqueous solution of sodium or potassium hydroxide. What we obtain? We obtain the sodium or potassium salt of carboxylic acid. After boiling process, what we obtain? Sodium or potassium salt of carboxylic acid, and this carboxylic acid are what? Fatty acids are formed. Now these salts which we obtain are termed as what? It is termed as soap. When soap is mixed with hard water, calcium and magnesium salt of fatty acids are formed. Now see, when we see that when we put a soap in a hard water, we get what? We get the leather. We get a scum which is generated on the leather on the level of water. So what is that? When soap is mixed with hard water, we get what? Calcium and magnesium salt of fatty acids are formed. That scums are with nothing but we get a calcium and magnesium salt of fatty acids. Now see students, we learned what? We learned the difference between soaps and detergents. Now see, soaps and detergents, what are the difference between this? Soaps are not effective in hard water and saline water. They are not effective, right? So because of that, we have seen we get a scum on the hard water, right? But detergents, they do not lose their effectiveness in hard water and saline water. They do not lose their effectiveness. They get mixed up and what? They does not lose their effectiveness in these waters. Soaps are completely biodegradable. Biodegradable means they can decompose very easily. They are biodegradable. They are not harmful for the environment. Detergents contain a branched hydrocarbon chains and are non-biodegradable. Now see, detergents contains what? It contains a branch of hydrocarbon chains and they are non-biodegradable. They does not decompose easily, hence they are harmful for the environment. They have a tendency to form a scum in a hard water environment. Here I have already told you, when soap is mixed with a hard water, we get a scum. Scum means what? Layer of dirt. Layer of dirt is obtained. While in detergent, this compound do not form scum. They do not form scum. Now here, they are derived from natural sources such as vegetable oils and animal fats. Now see, these are obtained what? These are obtained from natural sources such as vegetable oils or animal fats. While detergents are synthetic in derivatives, means it is synthetic in nature. They are not obtained from natural sources, right? So we all know that the synthetic materials, synthetic things are not easily decomposed, right? As it is not easily decomposed, it is very harmful for the environment. Huh? Soaps are environment friendly products since they are biodegradable. What? Soaps are what, students? They are environment friendly products and hence they are what? They are biodegradable. It is not harmful for the environment. While this compound can form a thick film that causes a death for the aquatic life. Now see, this detergents, the compound can form a thick forms, right? It's for a very thick form, and what they can, this is so harmful that it causes the death of a aquatic life. In aquatic life, it got also get affected by with the help of this detergents. Hence it is harmful, it is not eco-friendly, it is not environmental friendly, it is not biodegradable. Okay, so this is the difference between soaps and detergents which we have seen. Now we'll revise all these things with the help of a beautiful video, students.
Let us understand the properties and uses of bleaching powder. Bleaching powder is a yellowish white colored solid substance. Its chemical name is calcium oxychloride. It has a strong odor of chlorine gas. It is used for disinfection of drinking water at the waterworks and the water in the swimming pool. It is used for bleaching cloth. It is used for disinfection by the roadside and garbage sites. Reaction of dilute sulfuric acid and dilute hydrochloric acid with bleaching powder releases chlorine gas completely. Calcium oxychloride reacts slowly with carbon dioxide to form calcium carbonate and chlorine. You must have experienced that tap water has a typical strong odor in the rainy season. Water in a swimming pool also has the same odor. The odor is of the chlorine gas used to destroy the microbes in the water. Chlorine gas is a strong oxidizing agent. Therefore, it has a strong disinfecting as well as bleaching action. Chlorine, being present in the gaseous state, is inconvenient to handle. Instead, the solid bleaching powder, which has the same effect, is more convenient to use. Bleaching powder undergoes slow decomposition due to the carbon dioxide in air, and chlorine gas is released. Property of the bleaching powder is because of this release of chlorine gas. Bleaching powder is obtained by the reaction of chlorine gas with slaked lime. Now let us find out various types of bleaching powder available in the market and what distinguishes them from each other. The various types of bleaching powder available in market are bleaching powder containing chlorine, bleaching powder containing oxygen, bleaching powder containing peroxide, and bleaching powder containing reducing agent. The effectiveness of bleaching powder as disinfectant depends upon the chlorine content. The value of bleaching powder in the market is proportional to the quantity of available chlorine. Higher the chlorine content, higher is its price. Now let us understand the properties and uses of washing soda. Washing soda is a whitish and at room temperature. Red litmus paper blue. It is basic in nature. It is hygroscopic, that is, it absorbs moisture if left exposed to air. It is used mainly for washing clothes. It is used in the glass and paper industry. It is also used in refining of petrol. Sodium carbonate is a water-soluble salt of sodium. Crystalline sodium carbonate, on keeping, readily loses its water of crystallization. As a result, a white powder is obtained. This powder is called washing soda. Now, let us complete the reaction of sodium carbonate with sulfuric acid. Sodium carbonate reacts with sulfuric acid to give sodium sulfate, water, and carbon dioxide. Let us proceed further to study some crystalline salts. Crystalline salts which contain water of crystallization. We use a variety of salts which contain water of crystallization. Alum, borax, Epsom salt, barium chloride, sodium sulfate, and blue vitriol are some of the substances we use in our daily life which contain water of crystallization. Let us collect more information about the properties and uses of these substances. Alum and burnt alum is used in medicines. Alum is used in the paper industry to give shine to the paper. It is used to stop bleeding from wound. It is used in the process of purification of water. Borax is used in the cosmetic industry to make lotions, shampoos, and cold creams. It is used to remove stains from clothes in laundries. In the laboratory, with the help of borax bead test, basic elements from the colored salts are determined. Epsom salt is used in the manufacture of fertilizers. It is also used to enhance the green color of plants and vegetables. It is used as a body scrub. It is added in bath water to relieve muscle pain. Barium chloride is used in the purification of brine solution, that is, saturated sodium chloride solution. It is used in the wastewater management. It is used in the dye industry, ceramics, oil purification, and pesticides. Sodium sulfate is used in the preparation of detergents. It is used to make paper pulp in paper industry. It is also used in the dyes. Blue vitriol is used in the blood test to diagnose anemia. Blue vitriol and slaked lime is used in the Bordeaux mixture, which is used as a fungicide on fruits like grapes and muskmelon.
So students, this we have seen right now a video which we have done a revision of the topic which we have taught you today's. Now see students, some assignment I am giving you, write it down in your notebook, write down, give scientific explanation. You have to give scientific explanation. Number first, bleaching powder has the odor of chlorine. Why bleaching powder has the odor of chlorine? You have to write its scientific explanation. Second, the hard water of a well becomes soft on adding washing soda to it. Now, the hard water of a well becomes soft. Why becomes soft on adding washing soda to it? What are the products formed? What are the salt formed? That everything you have to explain in this explanation. Then soap forms a precipitate in a hard water. Why soap forms a precipitate in hard water? We have to explain all these three things. You have to give scientific explanation, take wrote down or take a screenshot of this and make it check with your teachers. Okay, so this is the lecture which I have conducted today. Tomorrow we'll see the third session for this chapter. So thank you for everything. Thank you for watching my videos.